Hello, everyone. Good evening. Thank you for joining me on this live coding session. My name is Ajulo Christian. I'm the Assistant Program Coordinator and Data Scientist at Amoye. Joining you from Port Harcourt, Nigeria. Welcome to the first live coding session brought to you by Amoye for the HDSC for 2022 cohorts. Thank you all for joining me. All right. Today we're going to be talking on some of the concepts in stage A. I'm going to be explaining some of the concepts as we code along, as basically introduction to pandas and NumPy, and some data wrangling, data manipulation, sorting, and all that. Okay, without wasting time, see the house already full. Let me just share my screen, and then we'll begin. All right. I hope everyone can hear me clearly. Okay. Share my screen.
Yes, what can I help you with?
All right. Can everybody see my screen? And if you can hear me, just drop a message on the chat so I know to continue. Okay. Okay, lovely. Okay, let's begin without wasting time. This stage A is basically dealing on introduction to Python for machine learning, and the libraries we'll be using will be NumPy and pandas for this stage A. Probably because of time, this session is supposed to last for 45 to 1 hour. So I'm just going to, I've already written down the codes there. I'm explaining what the codes are doing as I progress. Okay. So NumPy, as we already know, or NumPy, stands for numerical Python, is the backbone of all kinds of scientific and numerical computing in Python. It offers comprehensive mathematical functions, like the random numbers, generators, linear algebra routines, Fourier transforms, and more. So I'm not going to bore you with all these theory talks and all, so just go straight into the code. And also, Pandas is an open source library which helps you in analyzing and manipulating your data. It is fast, powerful, flexible, and easy to use. One of the main use cases you come across in using Pandas is to transform your data in a way which makes it usable with machine learning algorithms. Okay, so let's start from the code. At first, to run your NumPy, you have to import it, which is importing NumPy as NP, which is normal basic procedure. It's in the documentary. And here we're going to be defining some NumPy array. So there's a way you define ND array, and then a NumPy data type basically is an ND array. So an ND array is a collection of the data type, that's data type objects in the NumPy. So as I progress, you understand better, just follow along. Okay, first we have a one-dimensional array, two-dimensional array, and a three-dimensional array. I'm going to just create this using np.array. This is just like basic code for creating an array and like in the form of matrix. So here we're doing some basic wrangling of data, checking the shape, dimension, the data type, and the size of each of them. So if you notice for the A1, which is a one-dimensional array, it has an n dimension of 1, and the data type is integer. Okay, well, before I continue, data types in Python, we have numerical data type, which is the integers or the floats. The floats are the numerical data in decimals. Then we have the Boolean, which is the true or false. Then the integer 64, integer 32, or integer 8. So I'm not going to go details about that. So just running through of them. If you notice, the second one is a two-dimensional array, 2 by 3. Third one is a 2 by 3. That's the shape. Then these are the sizes and all that. These are some paper codes inbuilt in Python to check your shape, the dimension, and the data type and the size and whatnot. Okay. If you have any question by the end of the session, I would review them. So just drop it in the chat as we continue. So I'll review everything. Then let's see A3 that we created. So this is a 2 by 3 by 3 matrix. So before we continue, let me just explain basically what these matrices are. Right, moving on to the next. Okay. The next we have simple. I want to create a simple array. I want to show you guys something, but I don't know why this is coming up. Okay. All right. Okay, this is what I wanted to show you guys. The anatomy of a NumPy array. I hope you can see this particular part of my screen. For the first one, we did the one-dimensional array, a two-dimensional array, and a three-dimensional array. So the A3 we got as the shape 2 by 3 by 3 matrix. So as it's 0 is this 2, as it's 1 is the column. So this is just like an anatomy of a NumPy array. You can go back and try to understand better. So this is a 1 by 3, 2 by 3, and a 2 by 3 by 3 array. Okay, moving on. Creating a simple array, creating a matrix of ones, just showing this is a 4 by 2 array, 4 in the sense that 4 column by 2 row. An array of zeros using this particular code, 5 by 3 by 3. This 5 by 3 by 3 means a 5, which is these 5 columns, by 3, just like what I explained here, by 3, and there's this by this 3 here. So this is just basically what it means. So we have lots of things to cover. I'm not going to stay more on that. Then there's another way of creating, I'm just creating random numbers. There's a code in Python that you can do that called random.randint. It's creating random integers. I'm creating a numbers from 0 to 10, and the size is 5 by 3 matrix, which is 5 by 3. Then there's something else in Python called a random seed. For example, if I'm reloading this particular code, if you notice this first line is 179. If I run it again, it will show 677. So they're just creating random numbers. So, but if you use a function called np.random.seed that's creating random seeds, it will make whatever you're creating. If you run the code again, you get exact same answer. So if you notice I ran this code, I'm running it again, I'll get the same particular results. So that's for that. Then moving on, mind you, I'm still working on NumPy. I haven't got to pandas, so I'm just giving some preambles so you get to understand. And also we can create a data frame using pandas. I haven't got to pandas yet, but I just have to bring this out. So because as you're seeing, what we've done previously is just like matrix. So you can convert it to a data frame using this particular code. We're importing pandas as PD. So just drop a question in the chat, I would review it when I'm done. So if you notice this particular numbers which are in matrix, they are now in data frame, which is, this is the index and these are the columns. When I get to pandas, I'll explain better. Okay. Running our previous code before. Time disconnected. Okay. I'm having connection issues. Okay, come back. So now running back because I had runtime disconnection because I'm working with lab. Okay, checking the first index in this our A1 array. In Python, when you are calling your indexes, it starts from 0. So our first value in this index 0 is just 1. So these are just basic stuff on NumPy. So I'm not showing an example. For this 2-dimensional array, the first index is this particular row. And also for A3, this particular row here. That's the first thing I'm getting. I'm slicing for the first particular index. This is index 1, sorry, index 0 and index 1. So I'm just doing some preambles. When we go further, you understand better. This is just talks and talk. So now I want to get the second row index of A2, which is this second row. So there's a way I call it. I'll call A2 1. It will show me this particular index. I hope everybody can hear me clearly.
Yes, we can hear you.
Okay, thank you. All right. After that, moving on to the next, this particular code, what I want to do is to get the first 2 values of the first 2 rows of this A3 array. The first 2 values of the first 2 rows of this array. So I'm using this particular code in, this is an indexing code in Python, basically in NumPy. So if you don't understand that, you can always go back and watch this video again or do your research to understand what I'm doing. So basically what I just did in this code is to wrangle the data to get these first 2 rows, 1, 2, and that's the first 2 values of the first 2 rows, which is this 1, 2, 4, 5, and 10, 11, 13, 14. So when we start working with data frame, you understand why this is important. So I'm just doing sample data. So I'm creating another random number, random matrix. So this is a 2 by 3 by 4 by 5 matrix. Let me explain. The 2, which is this, you can see my scope as this 3 and this 3, that is the 2. Then by 3 matrix, which is 1, 2, 3, you can see my scroll bar, 1, 2, 3. Then by 4, which is 1, 2, 3, 4, just as I explained here, this row. Then by 5, which is 1, 2, 3, 4, 5. So this is just like another example. And the shape, you see the shape, 2 by 3, 2 by 3 by 4 by 5. Okay, doing some manipulations on NumPy. Let me call my A1 back. You can do np.sum. Remember, we called NumPy by calling it NumPy as np. So we can do np.sum. It will sum the array and give you a result, which is 1 plus 2 plus 3. Let me call back my A2. Then you can run a mean on this to get the mean of this particular matrix. These are just preambles. When we get to working with data frame, you understand better. So in case you don't understand, just drop a message in the chat. I'll explain. Okay, then we have getting the mean of this particular matrix is 3.6. You can also get the max using np.max.a2, the max value, which is this 6.5 here, if you can see my school bar. Then you can also find the minimum value, which would be 1. Brought out the answer. And you can also do standard deviation. It's a function in NumPy, which is np.std. Then you call the data frame or the sample you want to get your standard deviation for, and it's showing as 1.82. Then I'm getting the shape. So I want to add, I'm doing basic aggregation and manipulation with NumPy, working with 2 different matrices. So I want to see if we can add A2 and A3. Mind you, sometimes it will not work because of different shapes. If you notice, our A2 shape is 2 by 3, and the A3 shape is 2 by 3 by 3. So if you notice, okay, let me show you the A3 shape. So these are just basic wrangling and manipulations in NumPy. So to do that, I have to reshape this A2 to like this format for A3. That's when we can add both of them. So let's reshape. Then we can add both of them, then it gets your matrix. Voila. So this is another function, or should I call it module in NumPy. We can do .reshape, .shape, .standard deviation, the mean, the max, the sorting, the axsort. To know more about this, you can just go online and check more manipulations on NumPy. Then I can transpose, which means switching the axis of our A2. Our A2 was basically, if you can see it, our A2. 1 by 2, 1, 2, 3, 4, then we switched it. So it's now turned to a 3 by 2 matrix here in the shape. Okay, moving on. There's another process of working with NumPy, manipulations in NumPy. There's something called the dot product. The dot product. I'll answer your questions when I'm done. I'll answer. Okay, calling back my np dot random dot seed, creating a random matrix again. So I want to show you an example of how you can add 2 different data frame or matrix with using the dot method. Okay. So checking the shape of both of them. So I can have access to errors. All right, moving on. To do when I'm using dot method in NumPy, but again, you are working with dimensions, and if you notice the two report is showing what the error report is showing. So to do that, you have to Oh, sorry about that. I thought that I'm having network issues. Can everybody hear me and see my screen now? I guess I blacked out for a minute. Okay, sorry about that. So moving on, I want to check the shape of both matrices. This process I'm doing might just bore you, so I'm just trying to give you preambles before you go, so you get to understand when we work better with the other data frame. So now the best way to add both of them, since I've changed the shape to 5x3 and 3x5, so I can just do a dot product, which is multiplying both matrices together. So, okay, with this process, we just added both of them. So with all this boring I'll be giving you that probably you don't understand, let me start with a particular real life data set, although I actually forged it. So I'm going to be working with a SES data set. So I'm creating a data frame. First of all, I'm using random numbers. Then I'm creating a data frame from the SES amount. I'm creating the indexes and the columns. So this is just like a function in pandas to create data frame, pd.data frame, put in your key value pairs. So I'm not going to explain much about that. You understand better later. So we've gotten a data frame. So I guess we can work more with this instead of working with matrices. So with this, you can understand better what I was trying to say. So now I want to create a price column from scratch. So I'm using np.array 10, 8, 12 just to create a column. Let's see if it will add. Then I'm creating the prices, another data frame. So since this is already a one-dimensional array, I'm going to reshape this data so it will fit into this data frame. So these are part of data manipulation. And of course, as I'm going, you don't understand, this video is always available on YouTube. You can go back and follow along if you're not getting it. So why I'm rushing is because basically have many things to cover. So what I'm basically doing is just to create a data frame, and I created the price column. So now I want to add the total sales, which is for this price and the sales amount of this particular data frame and this data frame together using the dot product. And mind you, it will work because they are of different shapes. The first one is a one-dimensional, which is this, then the other is a three-dimensional. So to do that, I have to transpose my total sales column. Just try and follow along if you're not, or you drop your questions in the chat and I'll get it. So then after that, getting this total sales, I've already reshaped the sales amount, which was okay, yes, which was this. It was a one-dimensional array. Now I've reshaped it to that's transposed it and added it to the total sales. I don't know if you get me correctly. So let me create another particular data frame to see the shape. So now it's a 1x3 and 5x3 dimensional data frame. So they have the same shape. But mind you, you might still have to transpose it again because if you run it, it should throw error. So let's see if we can do the dot product of both shapes. And now we have a 1x5. So everything can work perfectly now, if you understand me. So let me just brush through showing the shape again. These are data manipulation with NumPy. It might not look sweet and understanding, but you understand better, I will start working with data frame. So let's see if it will work if we want to add the total sales to it again. So this will not work based on I've tried it before. This particular code. It's still showing, the error message is showing wrong number of items passed, 5. Placement implies 1, meaning I'm supposed to pass 1, 2, 3, 4, 5, but I pass just one. So I have to transpose the total sales column again. I'm creating a new column here to add to this particular data frame. We have the almond butter, the peanut butter, the cashew butter. So I'm creating a new column called total sales of everything. So now I have to transpose again my daily sales I wanted to create. Because I transposed it, it's now worked better by adding both of them. Before it was a one-dimensional array, that's 1 by 5. Now, sorry, 5 by 1, but now it's a 1 by 5 array. So that was how I could add it to this particular data. If you notice, it was not here. Mind you, as you're going forward, you can do other manipulation using pandas. So instead of this, so this is just a brush through with NumPy. So what I just did basically was just to show you what was in your course material about NumPy, manipulating data with NumPy, transposing, reshaping, and all that. So now getting to the main business of the day, which is pandas, working with pandas. So we have pandas data frame. Basically, the different data types in pandas, we have the series and data frame. The series is just like a one-dimensional column of data. Then data frame is a two-dimensional table of data with rows and columns. So you can create a series using pd.series and passing it to a Python list. And also you can create a data frame by using pd.dataframe and passing it to a Python dictionary. So I'm not going to go deep into how you create all this stuff. The documentations are there for you to briefly to get the hang of it. So first off, we're going to be importing the pandas, and I'm creating an example of a series data frame, a series and a data frame. So right here, I'm creating a series data frame called cars. So I'm just going to click on this to show me 3 different rows. Then moving on, I'm going to create a series. This was the car type. Mind you, these are called rows in a particular data frame. So I'm creating them using the series method. So I'm creating the cars. First of all, I'm getting the car types, then getting the color of each cars. Then now to put them in a data frame, these 2 particular series, I want to put them in a data frame. And the way you work with data frame, I don't know if you know what we call dictionary, which is a key value pair. Yeah. To work with data frame, I'm putting it in a variable. I'm calling pd.dataframe. This is the key. This is the value. The car type is the key. The cars is the value. The color here is the key. And the colors is the value. Based on from these 2 series we've gotten. And now I'm putting it in a data frame. So let's view car data. So I created these 2 columns using the series style, then putting them in a data frame using like a dictionary method, and I have my data frame. These are the indices, and this is the column, this is the rows. I will explain better as we move on. So to work with a real data set, based on creating data, I want to work with a real data set I already have, I created before on Excel or Google Sheets. So I'm importing them. If you notice in your materials, you already know how to import different styles using importing CSV or Excel or JSON. The basic command now I'm working to CSV, I'm using pd.read_CSV. They call the name of my CSV as saved. Then I want to view it. Okay, so this is my data frame. I hope you can see it clearly. This is my data frame. So let me explain what a pandas anatomy of a pandas data frame is. Let's go here. So from this data frame I have here, which is the make, the color, which is these are the rows, and these are the column. Let me explain better here. So these are the data in it. If you hear in Python, if you hear as is 1 or as is 0, as is 1 represents the column, as is 0 represents the rows. Then the index number normally starts from 0. That's the default method. Start from 0, then counting down. So this is just like a brief explanation of data frame. As this one is the row, is the column, the stuff. Then as 0 is the row. That's when you're doing your manipulation. You get to know better. Then moving on. Okay, let's take this one. I want to do some basic wrangling of data. I have the data types of this my data frame, which is the objects and integer. Like I said before, we have different type of data types. We have the integers, the floats, the objects. Objects are the categorical data. Mind you, since this make column is an object, it's showing objects which are non-numbers, Toyota, Honda, Toyota, BMW, and the rest. But odometer is integers and numerical. They're showing the numbers. Yeah, so that's what this code is doing to show the particular data type you're working with. Then another code to describe the data. This code is helpful when you are okay, yes, you can see it clearly. You can work with different things here too. With this describe, you get your count, your mean, your standard deviation, your minimum value. So this looks like a helper code to give you so many things about your data. So this basic wrangling of your data. Then I want to get the info of my data. It's just the info is doing something like these data types. It's showing me everything about it. It's showing me the number of entries from 0 to 9, data type, columns, the data type is integer, objects, memory usage, and all that, so forth and so on and so forth. Okay, then we have the classes to get the mean. So what I did before for that matrix data frame, I'm working on it with a real life data frame. So to get the mean, if you're calling this mean in a data frame, it will only work for numerical data. That's why it's showing results for odometer and doors. Odometer and doors are the only numerical data here, which is the integers. It does not work for categorical data. That's when you want to do machine learning, you now have to convert your data using one hot coding or whatever. So there's another code to show the columns if you can't go far back to where you've already written it. So this will show you your columns. Then I want to create a particular column, saving it to a list instead of me running this code again. So I can just run this particular code, classes.columns. And also to wrangle this particular, if you notice before, I'm still wrangling this particular series column. Yeah. To wrangle it, I can still call, since it's a series, I can still call the 0th index, which will show me the make. The make is the first one here in this my data frame. So I just called car columns, which is the variable I saved is car sales columns, and I called the first index, which is make, and gave me this make. So these are types of wrangling or methods of wrangling your data. Then we have the classes to get the index. There's another method to get the index. Starting from 0 to know your full data set, what you are working with. So this is another helpful process of getting it. Your data frame dot the index. It shows me start from 0, stops at 10 with step 1. So these are the index in my data set, which is this 0 to 9. Then performing other functions, to also know the length of your particular data frame, which is the same thing as 10. There's a function in Python called len. Okay. All right. There's another function to show if, for example, you're working with a full data set that is big, you can use what we call dot head to show you the first 5 rows, which is this. Show me the first 5 rows. And also with this dot head, if you want to check the first 6 or the first 7 rows, you can just put dot head in the bracket 6 to show you this. I just ran this before, just now. Then you can also check the last 5 rows in your data frame using your data frame dot tail. Dot tail will show you your last 5 rows, which is from 5 to 9. Based on working with a small data set. I hope everybody can hear me if I'm not just talking to myself. Can you hear me clearly?
Yes, please.
Yes, sir.
Okay, lovely. Hope I'm not too fast. But if I'm too fast, I'll come back again and explain.
You are too fast, sir.
Okay, anyone you miss, you can just drop it in the chat. I'll explain back. Okay, making working with iLock and lock. That's on that type of functions in pandas. First of all, the lock takes an integer as input and chooses from a series of data frame whichever index matches the number. So let me just show you an example. I've run this code before, so let me just run it again to show you. So here we're selecting the row at index 3 of this data frame from 0 to 3. So just pick this 0 to 3 using the .lock method. Just this index 3, which is the BMW black 117, it will show it in a series method. So if you are wrangling your data, you just want to collect only this particular row, you can use .location and get the index to bring that for you. Then while iLock does basically the same thing, it will just actually bring out the exact same position. So let me just do iLock. The difference between iLock and lock is that iLock will show you the exact same position. So for this, the exact same position is still this index 3 here. Okay, if you don't understand, I will explain again after I'm done with the session. Okay, I can also do slicing with lock. So if you don't understand what is lock and iLock, you can just go back and search on it to know the two differences between lock and iLock. Let me just run the code again. Showing this will show me all rows up to from 0 to 3 in our data frame here. I just want to select just from 0 to 3 to bring out just 0 to 3 instead of using head 3 or head 4. So I'm using iLock, the location of where my data is, and showing me from 0 to 3. Okay, so how do you know when you should use the iLock or the lock? First of all, you use iLock when you are referring to indexes, which is 0, 1, 2, 3. Then you use iLock when you're referring to positions in the data frame when index is out of power. So positions in data frame when index is out of power. So that's the two difference. And also, if you want to select a particular column, you can use the column name. I will explain more. I'll show you another example. For example, I want to get this column name, which is the color column. I can just use *scissors for the column to show me exactly what is in this particular column, which is the red, blue, black, white, green, whatever. And also, I can do selecting with Boolean indices. And Boolean will obviously data type true or false. So I want to select, using this code, select, our data frame has this odometer. I want to select the data from this, our data frame in the odometer that has an odometer kilometer less than or greater than 100. So anyone that has 11,000, it will not show up. So let me just show you the code to do that. So you can do that using a Boolean. Boolean is a greater than or less than. So here, I'll call my classes data frame. I call the particular column, which is the odometer column, and giving it a value greater than 100. I want to select only the particular column that the odometer has greater than 100. So these are parts of your data wrangling. And also, I want to check in my data sets the make that are just for Toyota, or that are just for Honda, or just for BMW. So I'm just wrangling the data also. This is a way to do that. To show me just the mix down of Toyota. But mind you, to not only show me the column, to show me all the columns that the maker Toyota, including the color, the odometer, in kilometer, the doors, the price, and whatnot. Okay, there's another function in Pandas called the pd.close tab. It's a great way to view two different columns together and compare them. So I want to compare the make column and the dot column. So I can just use a pd.cross tab. The class says make column and the class says dot column. And voila, it will compare both of them. It will show me this is the make, this is the doors. For BMW that has doors of 3, don't have any car there. It's only the BMW make that has a door of 5. And for Honda, it's just the make that has 4 doors. Same thing for Nissan, same thing for Toyota. This is just a way of getting to know your data sets more. And also there's another one called the group by. The group by, if you want to compare more columns in the contents of another column, you can use dot group by. In the contents of another column. For pd.cross tab, is just comparing both columns, but this one you want to compare your data frame using another column. So now I want to check the make and the mean of my column. I'll go back to your questions in the chat, don't worry. And like I said before, when you're working with means, we only work with numerical data, not categorical data. So if you notice, I work with odometer and the doors, which are numerical data. So I'm grouping by the make column, and I'm getting the mean of the make column. So I'm using a group by function. You'll see this probably in your quiz or not. So I'm just saying. Okay, manipulating data. This is the interesting part I'm waiting for. Manipulating data with pandas. If I want to make my data frame, because if you notice, these are already in caps lock, I want to make it to get a lower case. Everything will print out in lowercase. There's a function called the string.lower. There's another function manipulating your data. And then also, if I want to save it, because right now it is not saved, I want to save it to my data frame. That's a column. Let everything be lower cases. I'm running this code again. So if you notice, everything here is now in column. Before, this is series, but now I'm working with it in a data frame. This is series, this is a data frame. So another code or function to know if you have missing data is the ignore or isNar. So to check if I have missing data in this my data sets, I'll run the name of my data set dot ignore.sum to see if there's any missing data in the full data set. And if you notice, I don't have any missing data. It's showing 0, 0, 0, 0, 0, 0. Okay, so now every time you don't get to work with data frames that are clean. So I want to import another data frame that is not clean, that have missing data. I already have this with me. I might provide it after this session for you to work with. So I'm going to import that data. Mind you, it's bigger. If you notice, there's none. None means they are missing data. They are missing data in this row, missing data in this row, missing data in this row. So we can work with this. So I'll wrangle this data to see how to work with missing data. So if we check it, you see we have missing data. In the make column, we have 1. In the odometer column, we have 4 missing data in this data frame. So we get to see how we can handle missing data. So first of all, there's different methods of handling missing data. We have the feed-now, feed forward, feed backward. These are different ways of handling your missing data. And to know more about this, you can go back and check the documentations. That's the best way to understand it better. So this code I'm writing, I'm selecting the odometer column. I want to fill the missing data in this odometer column. So I'm using the feed-now method, calling the odometer column back. I'm filling it with the main value. Since it's a numerical column, I want to fill it with a main value. The main previously from what I was doing. So now that I said all these things we're doing will build up to what we want to do with a particular data set. So I want to fill this particular column with the mean data of everything in this column. So let's run that. And let's see, I'm missing data. If you notice, it's still not showing because we didn't put in place. So to do that again, this time around, if you run the data again, let's run this first. Ability. Okay, if you notice, it's now in place now. Have the missing data has been filled with the mean value of all the data in this odometer column. So if you notice, the mean value is 92302, 92302. So this is just a way of working with missing data in data set. So if we check it again, we notice that we still have missing data. So when it works with the missing data for the odometer column, now if you notice, we don't have any missing data in the odometer column. So there's another way of working with other missing data, depending on if your data set is large or not, or if the missing data are not that important as they're not much, you can just drop everything from your data set. So there's a code called drop now and the in place true. So I'm running this code. You notice that every other missing data we had have been dropped. So let me run it again. You notice now we don't have any missing data. Mind you, when you are using a drop now, it's only when you notice that you're missing data. When you notice that you're missing data, it's not that much. So that's when you work with drop now. So instead of using a filling data, what if you want to create a new column? For example, I want to create a new column called the engine size. So mind you, I'm just running a code to create a new column in this data frame called the engine size. So I'm calling, there's a way of doing it. I'm calling the column, creating a new column. I already created a variable called engine sizes, writing my random numbers, putting it in the car sales data frame. And I have this, it's already added to my data frame. So this is another way of wrangling your data to have your data frame. So I just added the engine size. And also, if I want to add another one called the number of wheels, I'm adding it to my data frame. So these are part of wrangling your data. I'll come back to the chat session if you don't understand. I'm just rushing through because of time. I can also remove a particular column by using the drop code. This is called the drop.the_column name and as is one. And mind you, what I said before, in data frame, as is one refers to your column, as zero refers to the rows. So I want to drop the column, I must call as is one to it. So I want to drop this engine size column using the .drop function and calling as is one so that you know that it's working with just this column. And if we do that, we don't have our engine size column. So these are just some, there are more to this. I just picked some few points for this stage based on it's just like an introduction part. So when you move on to stage B and all, you see more. So you can do your own research and to see more of how you wrangle your data. So now let me go back to the chat. Are there questions here? If you have any questions, you can drop it in chat now. Okay, I'm seeing one from Kafilat. You're saying, is C the function in NumPy library? Yes, it's a function in NumPy library. It basically means you having the same number of random numbers again. Instead of, for example, I want to create a random numbers. If I run that code, I come back to run the code again without setting a seed function, it will give me a totally different answer. So if you set np.random.seed, sometimes np.random.seed 0 or np.random.seed 42 or whatever, if you run that code again, you have the same answer. So that's just that for that particular question. Will the link be shared? The link is already shared on Slack. The link already posted on Slack. Just go, if you don't have it, just go to search on YouTube, Hamoye. You get this video is already streamed there live. So you can go back and watch it if you don't understand, if I'm too fast. So you can go back on your own time and check. And mind you, this is not a compulsory webinar. Attendance are not taken. Anyone who have a compulsory webinar, you'd be notified of if it's compulsory or not. So the Ask Me sessions and the live coding sessions are not compulsory webinars. So okay, yeah, from what you're saying, from the document, it says creating a data frame with dictionary and with list, it's meant to be the same result. I did, but the result looks like one is a transpose of another. Mind if you're creating a data frame, the way you create a data frame using not the series, using data frame, pd.data frame, it's like key value pairs, yeah? Or key value pairs. It's just like what I did when creating this particular data frame. I don't know if you saw it before. I don't know if you go back and check to see if you did it well. I don't know if I get your question correctly. But whenever you're working with the data frame using pd.data frame, it's always in a key value pair. It will transpose, it will not transpose and in a column. So that's how it does it. It works with like a dictionary method. Okay, let me stop sharing. So can we select a specified data? For example, can we pick 6,000 from the... Yes, you can. If you notice what I did basically is just to, most times I just created my own data set from, but when you're working professionally, you won't get to create your own data, but it's good to know this particular skill. So you can create whatever way you want to create it. There are random.round it. So you can pick whatever form you want to pick. So I guess I've answered the question, Kafilat. If I've not, you can still drop it again if I've not. Okay. Okay, I should talk more about the 2x3x3 array. Okay, the 2x3x3 array, like I said previously, is just like a 2 array by the 3 rows by the 3 column. It's just that there's no way I can explain it more. Just search on Google, you see a pictorial depiction of it, just like what I did previously. Okay, there's another question saying when does Python consider a data empty? Read files will not have noun, I think. Okay, most times you basically see none. You basically see none when you're working with your data frame. And since if you're working with a very large data frame, you cannot probably see everything at once. That's why you need to use a function called pd.isna or itsno.sum. If you just run your code of pd.isno, it will show you, it will give you a Boolean data frame showing true, where there's a missing data to show, when there's a missing data to show true, when there's not a missing data to show false. So, but if you now call pd.isna.sum, it will show you the full data frame and each column that has a missing data. That's where you now start working. Because most times you'll be working with large data frame. When we get to stage B, another coding session with words, I'll show you an example of working with large data frame, like 10,000 columns, 10,000 rows, because what we just worked with is just 10 rows. So when we work with that in stage B, you'll get to understand better on how to know your missing data. Any other question? Any other question, drop it on the chat. People still asking about the live video. It is already streaming on our YouTube channel. You can go back and watch it. It is there. Search for Harmony HQ. You can also subscribe to get more of the video. So I've answered that question previously. So any other question? If you don't want to drop it in the chat, you can unmute. So I have time for one last question before we call it a day. Okay. There's a question. When using imports, do I need to import pandas or NumPy for every session? No. That's why when I started, I imported my NumPy and my pandas. And mind, if I'm working with Jupyter Notebook or Google Colab, it works with runtime. Once you've already imported it, and you can work continuously if the runtime is still on. But if you close that notebook and come back again, you have to rerun that import. That's what it means. So you only have to rerun it every time when you've closed the notebook or the runtime is over. So Dario, do you have a question? Last question before I call it a day. Okay, lovely. So in the absence of no further question, thank you everyone for joining me. I hope you enjoyed this
Thank you very much.
session. Okay.
Thank you, sir.
Okay. Okay. And also, if probably I was too fast, you don't understand, the video is always available on our YouTube channel. You can go back and cross-check the video, what I taught on it, and also the materials on the platform and your personal research. So there are many things I didn't cover. I just did some few touches around it. There are many things I didn't cover. You can go back and check on the documentations on pandas and NumPy. You see how you wrangle your data, how you perform data manipulation, aggregation, Boolean functions, and the rest. So just do research, play around it. If in doubt, like my mentor will always say, if in doubt, run the codes. Even if you throw an error, your Jupyter Notebook or Colab will always show you the error message. Then you can search on Google to know what the issues are. Lots of resources around. So I guess we've come to the end of today's session. This was very eventful and fun. Thank you everyone for joining me. Like I said, you can go back to the video to understand better if I was pretty fast. I know I was fast. So we do this next time. Always put an eye on the Slack channel, and to reiterate, the Slack channel is the primary form of communication. The announcement channel, the Ask AMOU team channel, you can drop your questions, even relating to the course. Parts you don't understand, you can screenshot or drop your questions. We'd answer. Mind you, we don't answer questions related to the quiz, so don't bother if you're asking questions about the quiz or dropping it. You won't get answers on that. Then sometimes our questions have already been answered. There are articles written. Some persons asking these questions again, like how to take the quiz, how to navigate the platform. Check the announcement channel. There are helpful articles that are already dropped there for you to understand. So before you ask a question, always scroll through up to see if the question has already been answered. But if it has not been answered, you can ask and the team would reply, or any other intern that's already passed through that place can also reply. So once again, thank you very much for joining me. My name is Arjuno Christian. I'm the Assistant Programs Coordinator at HDSC. I'm also a data scientist. See you next time. You always have your information on Slack when we're having the next live coding session. To reiterate, we won't be having Ask Me sessions again, just live coding sessions for each subsequent stages. Okay, thank you very much. Have a lovely day. See you next time. Bye for now.